Good morning. Thank you for being here. Today I will be presenting my Keystone project titled Quantifying Restoration Success in the Belize Barrier Reef using underwater and aerial drone imagery. I'd like to thank Dr. Les Kaufman and Dr. Ethan Dial for all their tremendous support here in Boston, as well as the support I received in Belize from colleagues where I had the opportunity to travel with the support of the Kilachand Honors College. Let's dive right in. So what is a coral reef? If you were to observe a coral reef, you may think it's a simple organism that looks like a rock. However, corals are actually animals, and these create a mosaic of one of the most biodiverse ecosystems on the planet, which are visible from outer space. Stony corals, such as the one seen in this photo, are made of coral polyps, which are best observed under the microscope. These polyps produce calcium carbonate skeletons, which make up the reef structure. To survive, corals rely on a symbiotic relationship with photosynthetic algae. In addition, corals are highly sensitive to changes in water temperature, light exposure, and pollutants, making them especially vulnerable in the face of climate change. So the Belize Barrier Reef is the second largest coral reef on Earth, and it provides many ecosystem services. So these include shoreline protection, so protecting coastal communities from storm damage and erosion. The Belize Barrier Reef supports fisheries benefits, supporting the local food supply and people's livelihoods. In addition, there's tourism and economic benefits, and of course, there's coral reefs provide habitat for marine life. Despite making up less than 1% of Earth's surface, they support a quarter of all marine life. And there's recreation and aesthetic value. So despite their numerous benefits, corals are experiencing tremendous stress due to climate change and local impacts. Bleaching, as shown here, is the first sign of stress. When a coral is under stress, the polyp expels their algal symbionts and no longer are receiving those essential nutrients. This causes corals to lose their pigment and turn white. A common misconception is that bleached corals are dead. However, if those stressful conditions improve, such as water temperatures returning to normal, then corals can show signs of recovery in the span of weeks to months, as shown here with this Acropora palmata colony. So this raises really interesting questions about the potential of coral resilience in the face of climate change. It also leads to decisions in adaptive management strategies. So to address this, Fragments of Hope, which is a nonprofit led by local Belizeans, emerged in Placencia, Belize. They began restoration of Laughing Bird Key National Park in 2006. That's shown here at the bottom of the map, and that's the restoration study site of this project. So let's kind of share. The two species that we will focus on today are the acroporoid corals, so staghorn coral or Acropora cervicornis is shown on the left, and then the elkhorn coral or Acropora palmata is shown to the right. So these species were identified in underwater and aerial drone images at Laughing Bird Key National Park for my project, and what those drone images look like are essentially this. So this is a series of drone images over the course of 3 years at 6 different restoration sites within Laughing Bird Key National Park. So we're seeing that the most of the acroporoid cover are recovering at these restoration sites, which makes sense, but how much coral cover is there and how has that changed over time are the really interesting questions that this project addresses. So you can see that for this project, the different species were identified in these drone images, and then they were quantified. So over the course of just 1 year, we're seeing preliminary results from these drone images showing a nearly 14% increase in coral cover between Acropora cervicornis, Acropora palmata, and then their hybrid, the fused staghorn coral, the Aquapora palmata. And then we can take this a step further by looking at a longer time span, as shown here. So this is still at Laughing Bird Key, but it's focusing on 4 restoration sites. And I'd like to draw your attention to Site 24, which is shown in that purple line. We're seeing an increase of, on average, essentially 13% in coral cover, which is reflected in the drone images as well as the underwater images. So this is a quantitative approach to this qualitative restoration that we're also seeing in this time-lapse series of coral growth at restoration site 24. So essentially you're seeing the transformation of rubble to reef. And then this project also contributes to a data science pipeline of underwater orthomosaics. So an orthomosaic is a composite of high-resolution images that create one image that is geographically accurate. And what we've done is we've trained an algorithm to accurately identify coral species at the plot level using a standard approach called point annotation, as shown here. So essentially, you're throwing 1,000 randomly generated points across over 1,000 images to receive a high accuracy of about 90% using machine learning to identify these coral species. So this work will strengthen long-term monitoring and provide critical guidance to adaptive restoration efforts as a strategy for successful coral reef restoration. And I'd like to share some takeaways and conclusions. So with this emerging technology, there's a lot of opportunities, but there's also challenges. So some opportunities are that we can realize insights across spatial scales, both at the plot level, but then using those drone images. And this contributes to long-term monitoring of coral cover and growth. And all of this data is geo-referenced to provide accurate maps of the coral restoration sites. And then some challenges. Those in the drone images, lower resolution of the images can make identification of the coral species a challenge. And then we can assume that this is an underestimation because you're essentially seeing a bird's eye view and losing the complexity of what we know are those 3D structures. And similarly, it only captures the mature shallow water corals. So by leveraging this image data, we can bridge the gap between large-scale aerial mapping and fine-scale underwater diver surveys to strengthen long-term monitoring efforts and support adaptive restoration as a strategy for successful coral reef restoration. Thank you. Yeah. Yes, hi. Thank you for being here.
Oh, no, I wouldn't miss it. Hannah, when we extend the data baseline through 2024 and 2025, we see that the national park, which had been almost entirely restored by fragments of hope, I just came back from there, 99% of it is dead. One of the downsides of this technology is that it shows you the stark truth. How should we use your work to tell a hopeful story to people who are now challenging the whole idea of coral restoration?
Yeah. I think these images, as you're saying, provide the truthful story. And depending on how an individual sees that, you can find hope in that. But I think showing the progress that's made when using aggressive adaptive restoration shows that there's potential for, as we were showing before, rubble to turn into reef, and that despite the loss of biodiversity, there's a potential that's worth investment and worth hope to recover these ecosystems, especially taking into consideration all of the benefits that they provide to coastal communities worldwide.
Hi, this was really good. I don't have a lot of experience with coral, so I was just wondering, after it gets bleached, is there like a certain amount of time you have for the conditions to change before that coral does die, or is it like super variable between different types?
Yeah, so it is very variable. As we're seeing in this example, this was over the span of like 3 weeks. So it's quite rapid recovery, but what needs to be taken into account is the damage that that coral has received, whether that's from vessels dragging anchors, or if this coral is experiencing disease, which contributes to further like hindrance for the recovery, and then what is the difference between those stressful conditions improving? So how much has the water temperature returned to normal? So I think, as you were kind of alluding to, it is highly variable, but this is an opportunity for hope, seeing that a bleached coral is not dead. It has the potential to recover if those stressful conditions return to normal.
Hi, so I know you went to Belize twice, actually, to analyze these two different species of corals. So just a fun, lighthearted question, what was your most memorable highlight of the trip?
Yeah, thank you for that question. So, yeah, as I mentioned earlier, I had the wonderful opportunity to travel to Belize to kind of see these ecosystems firsthand. And I think what was most memorable was just the amount of passion, but also care that the local Belizeans have for these ecosystems, and seeing how there's an intrinsic relationship between these coastal communities and then these marine ecosystems that provide so much to them, whether that's the shoreline protection or their livelihood, being able to go out, catch fish, and have food on the table. It's all connected between these ecosystems and the coastal communities.
Thank you so much, Hannah.
Thank you.